Hello everyone, my name is Adam Patanascio and welcome to the Analytics Lakehouse demo. Today we're going to demonstrate how to build an Analytics Lakehouse from end to end in Google Cloud. An Analytics Lakehouse combines the benefits of data lakes and warehouses. We will create a unified platform for users, data engineers, data scientists, and analysts. You will see AI along with an open architecture to power your business. This is Rideshare Plus. It's a fictitious business that we've created to highlight building an analytics lakehouse using Google's Data Cloud. We're going to spend the next 20 minutes showing you how we predict the most profitable pickup locations for our hard-working rideshare drivers. Every driver wants to maximize their profits, and we are here to help. But first, let's take a look at how Rideshare Plus works for drivers. Before getting predictions, our rideshare driver has an important decision to make. They need to choose what kind of trip they want to make. Do they want to stay within a few block radius, or do they have time for driving across town? This decision is factored into the prediction data model to make the recommendations specific for them. Since we physically cannot change the current weather, we have a couple of options to simulate different weather conditions. When I click the Predict Now button, our AI will assign a score for each of the 265 pickup locations within the city. It takes into account the current date, trip distance, time of day, and the weather. It incorporates recent image analysis from each pickup location to search for people possibly with suitcases or carrying heavy packages. The power of building an analytics lakehouse is that you can combine and process unstructured, semi-structured, and structured data. We will also incorporate real-time streaming data, image object detection, and utilize shared data assets. Our driver can now see their recommendations by viewing this dashboard, which was built in Looker Studio and embedded into the driver's website. They can see the predicted data along with real-time data streams so they can select one of the high-value locations. On the map, the driver can see each pickup location along with how many trips are currently in progress. In addition to getting these personalized custom recommendations, they can also look at real-time data analysis from across the city. This dashboard provides a high-level overview of the current environment. The data you are seeing consists of thousands of events per second, which lands in our raw zone of the lakehouse. The event telemetry is then consolidated and organized inside the enriched zone. Final calculations with the data are performed in the curated zone. All of this is happening in real time and presented to the drivers. Let's take a look at what's happening inside our lakehouse. Here we will walk through each zone and explore how we built this solution. First, let's view our data sources, which consist of a variety of formats. So this is the raw bucket that holds our data for the raw zone. We have our payment type data, which is a JSON file. We have a trip table that consists of Avro, JSON, and Parquet. And we also have a zone table that consists of a CSV file. So I'm going to head over to BigQuery and look at our data set. So we have a data set and we have those same tables, those same set of files represented as tables within BigQuery. So let's go ahead and query them. So this is our Parquet data. So we can run this query and we'll go ahead and see the results, and we see our data from our Parquet files. And then this is a CSV file and we can see the results from our CSV file. Now what I'm going to do is apply a row level access policy to our CSV file. Since these are BigLake tables, I can filter for specific users or groups, and I can say filter using an expression, and here I'm going to limit them to seeing data that says Manhattan. So when I run this, you'll see we'll get a warning message that certain results are only being shown, and you can see the data has been filtered. So I'm going to click on the table, click Edit Schema. I'll click on Service Zone and add a policy tag, and I'll go ahead and do a data masking policy on this data. So this is our CSV file, so we're going to apply a second policy. The first one limits our number of rows, and the second one will null out the service zone. So there's a variety of rules you can do for data masking, and this will allow you to go ahead and hide that data. So another thing we'd like to do is bring over some data from AWS. So we have a table that we're going to create directly from BigQuery that has the data we want to run some analysis on, and then bring that data into BigQuery. So in this case, we've created an external table, and you can see we have a table created over in AWS. And we're going to go ahead and run a select statement that does some aggregations, but it's going to materialize the results back into our raw zone within the Google Cloud. So this is going to go ahead and create a table, and it's going to run the query, transfer the results back to Google Cloud, and create the table. So now when I select star from this table, you can see we have the results transferred back to Google Cloud. So BigLake tables let you do row, column, and data masking security. And next we'll go ahead and take a look at our unstructured data. We have unstructured data inside our rideshare images folder. So here's a rideshare images folder, and we have lots of different images that have been taken at various locations. So let's see how we can incorporate them into our analysis. So if I click on an image, you can see the image and some attributes about the image. And we also have metadata, so we know the location that this image was taken. So instead of clicking through millions or billions of files trying to find certain images, we want to make that easier. And here we're going to go ahead and create an object table over that directory. So this creates a metadata table that lets us retrieve the data about the images, and then we can go ahead and apply security or governance to those images. So I'm going to select star from that table, and you can see this is the same set of images, and we also have metadata about those specific images. If we wanted to, we could actually filter by certain metadata elements and apply security to those images. The last part of our raw zone is our streaming ingestion. BigQuery makes it easy to ingest streaming data and query in real time. Here in Dataflow, we can see our job, which is reading from a pub sub topic, our messaging system, and it's streaming data directly into BigQuery at thousands of rows per second. So let's head back to BigQuery and query this data. So this is the table, and we can simply run select star on it, and this makes it very easy for users to query and interact with real-time data. And with Dataflow, there's no hardware to manage. It scales vertically and horizontally, and you don't have to worry about upgrades or even setting up clusters. So let's go ahead and recap our raw zone. So our raw zone has many different file formats that we can query and secure with BigLake tables. We can even query data in other clouds using OMNI. Our raw zone contains unstructured data that we can query using BigLake object tables. All the different file formats can be secured with row or column level security and data masking policies. And streaming data is directly fed into BigQuery, which can be read with any SQL compliant tool or open source software. Now let's take a look at our enriched zone. We need to transform and enrich this information so it's useful. First, we will process our images. We want to understand what is happening within our images so our drivers get recommendations based upon what people are doing at each location. Here we can see how Vertex AI can extract information from our images. We want to be able to determine if people are traveling with suitcases that might need a ride, carrying shopping bags from certain retailers, or simply count the number of people within the image. Let's see how we can use our object table within BigQuery to extract this information. Here we have our object table query, and we have a remote function which calls Vertex AI. You can also call Vertex AI directly from BigQuery now without executing a remote function. So I'll go ahead and run this, and we can see our results. So within this image, we've detected a couple cars, and we've seen our score along with the raw JSON data. So I went ahead and processed all the images in our raw zone. So this includes the object detection, the labels, the landmarks, and logos, so we can extract even more valuable information. Now let's check on how we've transformed our semi-structured and structured data. With any system, we will be receiving updates, inserts, and even schema changes. In this scenario, we decided to process the data using Spark. We will read the data from our raw zone and process into Apache Iceberg format within our enriched zone. Iceberg supports data updates, schema and partition evolution, and time travel. We all know that data formats change over time and schemas evolve with fields being added and removed. We decided to use our data using Iceberg to solve these challenges. Here you can see our Iceberg files that contain our metadata along with our data files. Let's go ahead and click metadata. And you can see we have our 3 different tables created within our Iceberg catalog. So Iceberg can be accessed with any open source technology, which avoids vendor lock-in with your data. We can also query this data directly within BigQuery. Let's look at our Enriched zone here, and you can see we have our Iceberg files. So our JSON, Avro, and Parquet has now been transformed into Iceberg, and we can query this data directly in BigQuery like any other table. So it's going to go ahead and run a query on each of these, and we can see we get our results back. So these act just like any other tables. Data engineers and users can use this data, and they can go ahead and perform analysis within the Enriched zone. So how did we process this data? We use Spark to process our data. We use standard PySpark code, which can be run via any distribution of Spark. Here we are using BigSpark, which utilizes our Serverless Spark service to make executing Spark as easy as running a SQL statement. At the top of the code, you can see we are using a BigLake Metastore, which will allow us to track the latest version of our Iceberg tables automatically. As data changes in our tables, Iceberg generates new manifest files, and BigLake Metastore ensures our changes are kept in sync between systems like Spark and BigQuery. The rest of the code here is simply standard Spark code, and we do a reference up here to our Metastore so we can keep our Iceberg files in sync. So to recap, our Enriched zone adds intelligence to our images by calling to Vertex AI. Our Enriched zone utilizes Iceberg to support an open ecosystem. We have further enriched our raw data with Spark. We can apply our same security controls of BigLake on our Iceberg tables. Now let's bring all of our work together before exploring the curated zone. We are starting to get a lot of zones and storage accounts. So how can we easily keep track and secure our assets? We can see our entire lakehouse with Dataplex. Dataplex provides an easy way to manage our zones by grouping together related resources. Here we can see our raw, enriched, and curated zones. If we click on the curated zone, we can see our unstructured and structured data. One is stored within a storage bucket, and the other is stored within BigQuery. Dataplex will automatically scan these zones and register new artifacts. For instance, if you drop a CSV file in your storage system, Dataplex will automatically create an external table link within BigQuery so users can easily access that data. In terms of security, we can secure our entire lakehouse by looking at the resource-centric view. Here we can see our rideshare lakehouse and the various zones. We can set permissions at any of these levels, which means we do not have to navigate to each and every individual resource to set permissions. This makes setting permissions extremely easy. The principal-centric view allows you to pick a user, and you can see what permissions they have access to. This will let you easily see for each user what data lakes and zones they have access to, along with the roles they are assigned. To make our data available to other users, tables are automatically discovered and placed in our data catalog. Here we're going to click on the rideshare trip table, and this table has been automatically registered with data catalog, and we've done a data quality check on this table to ensure that we build a machine learning model with trusted data. So here you can see our data quality results. That is a scan that was done using Dataplex, and then the data quality actually goes down to the column level. So we can now see that our data is clean and that we can trust it. Also, we can explore the full history of lineage of this table. So within here, I can click on an individual node, or I can see the, here I can see the BigLake Metastore, and I can follow the data through the various transformations, and we can see the job ID and the SQL that was executed to transform this data. So now that we know we can trust our data, let's build our predictive data model. So back within BigQuery, we're going to view our curated zone. The first thing we can take a look at is we have ingested our data into the curated zone. So we now have tables directly within BigQuery. This will ensure fast and scalable access to our data to be able to take advantage of native BigQuery functionality, such as BigSearch. So here we can count the number of records in our rideshare trip table, and we have about 92 million records. I've gone ahead and created a search index over the entire table, and in this case we're going to search for a credit card number that hasn't been partitioned or clustered by, and we can quickly find this credit card number in these 92 million rows. In this instance, I'm going to search the entire table, all columns, and search for the same credit card number. So if we do not know the column name we might be searching for or what column our data is contained in, we can also do a search across the entire table. We also have further curated our images. So the data now has been extracted, and we'll take a look at this. So each image has been broken apart, and the name of each extraction has been placed in a column with the corresponding score. So we know our images are tagged with a location attribute. So our machine learning is going to use this attribute to know the location each of our images was taken at. Now let's take a look at the machine learning model used to predict the high value pickups. So we're going to go ahead and open up this routine and look at the model training, and we'll go ahead and edit this store procedure. The first portion of our machine learning query will gather the rideshare data. So this is our trips data that has been gathered so we can do our training on this model. The second piece is going to gather weather data. We don't have weather data in our system, so what we did is we went to Analytics Hub and we searched for weather, and we brought in a public data set that contains our daily weather data. So we went ahead and brought this data set in, and you can see it's linked here, and we can access this data just like a normal table within our query. So we have our rain data and we have our snow data that has been brought in through Analytics Hub. We also want the location and the counts of people. So we're looking for people that are traveling with luggage and bags, rolling in suitcases, and we're going to count them as people traveling. And then we're going to also just count the people in general. So this is our extracted data from our unstructured images that we're now using to generate our model. So at the bottom here, we have our query, and this will go ahead and look at high value rides. So the model has been trained, and this query will actually return back our high value rides and our prediction values. So we have the results inside a table that we can then use when we score this data and share with our Looker dashboard. The model can also be run and scored with our explain prediction. So I'm going to go ahead and run this, and this is going to score these values, but what it will do is it will actually break apart the features that contributed to the score of this model. So this is vitally important so we can know if we have bias in our model, and in some cases to make sure we comply with laws and regulations. So one item to note about our model is that it's not just limited to being used within BigQuery. Here we're actually using an update statement to go ahead and score all of our data, but the model has been placed within Vertex AI, and you can see right here we have our Vertex AI is our model registry, and if we head over to Vertex AI, we can then take a look at our model and see how we can use this in other applications. The model can now be hosted with a REST API endpoint since it's in Vertex AI. So we can easily click deploy to endpoint. We can define our location, and we can also do things like model monitoring, and this will allow us to do things like training skew and drift detection. So your custom applications can call this REST API endpoint and score data. So in addition, you can import TensorFlow models into BigQuery so scoring data is easy. Scoring billions of rows of data is time consuming when you have to read all the data out of your warehouse, score it, and re-ingest the results back into your warehouse. Now that we've trained our model, our website can pass in the parameters, and we can score every location in the city to predict high value pickup locations. Now let's recap the curated zone. Our curated zone contains our data in an easy and ready to use format. The zone is optimized for querying and searching. Our machine learning was trained using structured, unstructured, and shared data assets. We can scale our requests to thousands of users. That's how easy it is to build an end-to-end analytics lakehouse powered by Google Cloud. All the code for the demo is on the GitHub site contained in the description, and you can try the demo for yourself. Thanks for watching. Bye.